Hello everyone, today we're going to go through prime factor decomposition, and if we have time, highest common factor and lowest common multiple. I may split this video into two parts, so stay tuned for both parts. Okay, firstly I'm going to go through what factors are. Factors are, well, if you've got a number and it's a factor of another number if it divides into that number with no remainder. So to explain in simple terms, if you can make a number using the times tables, then you've got a factor. So here's an example. 48 can be made from 1, 2, 3, 4, 6, 8, 12, 16, 24 and 48. Why? Well, 1 times 48 is 48, 2 times 24 is 48, 3 times 16 is 48, 4 times 12 is 48, 6 8s are 48, 8 6s are 48, and 12 4s are 48. So a number is a factor of another number if it divides into that number with no remainder. Really important to know what a factor is. Common factor is a number that divides two others, then it's a common factor. So here's an example. We went through the factors of 48, 1 and 48. 2 and 24, 3 and 16, 4 and 12, 6 and 8. If we look at 64 as well, that's 1 and 64, 2 and 32, 4 and 16, 8 times 8. So I've circled all the numbers that are the same in both 64 and 48. So the common factors of 48 and 64 are 1, 2, 4, 8 and 16. So you have to look at what's the same between the two. Using common factors. So say we had a fraction. We could use the common factors to simplify it. So 64 over 48 is 8 times 8. And 48 is 6 times 8. Because there's an 8 on the top and the bottom, those 8s are going to cancel. So I've got 8 over 6 left. And 8 over 6 is the same as 4 times 2. And 6 is 3 times 2, 2's are going to cancel. Gives me 4/3 as an answer. This simplification has taken 2 steps. There is another way to get straight to the answer, and that is to use the highest common factor. Now the highest common factor is 16, because 16 times 4 is 64, and 16 times 3 is 48. Cancel out your 16s, and we go straight from 64 over 48 to 4/3. This is a really important thing to be able to do, cancel down fractions. I will put a link in the description box below to some questions on cancelling of fractions using common factors. It's something that everyone should be able to do, but it does rely upon knowing times tables. Primes. A prime number is divisible by itself and 1 only. So here are some examples on the left. 2, which is 2 times 1, 3, which is 3 times 1, 5, which is 5 times 1, 7, which is 7 times 1, 11, which is 11 times 1, and 13, which is 13 times 1. So I'll just give myself a little bit more room there. Note, 1 is not a prime number because its only factor is itself. Yeah? So, to just spell that out, 1 equals 1 times 1. So because the only factor is 1, it can't be prime. It's got to be divisible by itself and 1. So the fact that it's 1 is not a prime number. It's a square number, but not a prime number. 8 is not a prime number. And why is 8 not a prime number? Well, 8 is 8 times 1, but it's also 2 times 4. The fact that 8 is divisible by both 4 and 2 means that it's not prime. We can use the fact that these numbers are prime. 2 times 1, 3 times 1, 5 times 1, 7 times 1, 11 times 1, and so on, to help us break down bigger numbers into smaller ones. So I'm going to go through an example on the next slide of that. And this process is called prime factor decomposition. So prime numbers can be used to break down bigger numbers into the common factors. If you can divide it by a prime, usually 2, then you can break it down. So, the number 108, if I was to halve 108, I would get 2 and 54. Halving it would give me 54. Halving 54 would give me 27. Now 27 is not divisible by 2, but it is divisible by 3. So if I divided 27 by 3, I'd get 9, and then 9 is divisible by 3 times 3. Okay, so you see what I've done there? I've broken the 108 down into its various prime numbers by saying, well, what can I divide the big number by to get to a smaller number? And I circle all the primes because they're helpful to spell out what 108 actually is. So you should be able to see that there's 2 2s there and 3 3s, which means that 108 is 2 times 2 times 3 times 3 times 3, or 2 squared times 3. Another example, 144. Well, this time I'm not going to break it down into 2s. I'm going to break it into 12s instead. Why 12 times 12? Well, 144 famously is 12 times 12. 12 is not a prime number because other numbers will divide 12. But it does allow me to break the 12s down. So a 12 can be divided into 3 times 4 and 3 times 4, which you can see here. And the 4 can be broken down into 2 2s. So that means 144 is going to give 2 times 2 times 2 times 2 times 3 times 3, which is 2 to the power 4 times 3 squared. Now I know what you're thinking, this might sound a little bit tricky because I'm using numbers that are pre-prepped on a slide. So I'm going to do it live now on a fresh slide. Let's break down some numbers into their primes, or prime factor decompose them. Let us take 60 and 72. I'm going to break them down for you live, and then you can have a go at some of these questions yourself. I'll put links in the description box below. So 60, let's think about this. If I know my times tables, I should know that 60 is 5 times 12. 5 is a prime number, so I can circle 5. 12, well 12, that could be 2 and 6. Because 2 times 6 is 12, I can then circle the 2. And 6 finally, that's 2 and 3. Circling them, I've got 2 and 3. Okay, what about 72? Well, that's also in times table, so that's 8 times 9. 8 times 9 is 72. The 9 can be broken down into 3 times 3 because 3 times 3 is 9, and 3 is a prime number as we've already discussed. So then what about 8? 8 is going to be 2 times 4. 2 is prime, 4 is not, because 2 times 2 will make 4, and I can split this 4 into that 2 times 2. And circle my primes. So now, to make things a little bit more straightforward, I can say, well, 60 equals, how many 2's have I got? I've got 2 2's for 60, so it's 2 times 2 times 3 times 5. And 72 is 3 2's and 2 3's. And that's it. Except I can simplify this a little bit more by breaking those numbers into their powers. So 2 times 2 is 2 squared, times 3 to the power 1, which I'm going to put in, times 5 to the power 1, which I'm also going to put in. And then 72, that's going to be 2 to the power 3 times 3 squared. Now I'm going to go through why we do that later. Like, this part is the most important part, but this part is also important for later on. But I'll explain it to you a little bit later. Stay tuned for the next video, and I will go into highest common factor and lowest common multiple. Hi everyone, this is a friendly reminder to like, subscribe and hit the bell notification icon to stay tuned for future videos on this channel. I also welcome constructive comments in the box below, and you can gain access to any of my teaching resources through the link above. If you'd like to support me through donation, you can either go to paypal.me/JonathanKipping or patreon.com/JonathanKipping. Stay tuned and look forward to future videos.